And with that, I think we're good.
Okay, hello everybody. Hi and welcome to the 31st edition of Rust Linz. We are back again after a short break, after a little pause. We are here again and we are now, that's Rainer, that's me, we are on the same location. Wow! And as you can see, we are now doing a hybrid mode. So everybody who's joining us online, hi, and everybody who's joining us on the, what's it called, the Belle Etage, the beautiful deck at Grand Garage, welcome to you as well. So
maybe we should do a show of hands so that people know that we are really not alone here, but there are really people here, right? Yeah, awesome. Rust Linz is back.
Cool. Alrighty. So shall we go to the next slide? Okay. All right. It takes a little longer because Rainer has to run to his place. Okay. So as always, Rust Linz is brought to you by the Coding Club Linz. It's a non-profit organization doing events around coding in Linz. And that brings me to today's speakers. So first we start with an online talk given by Maxime David. I hope I pronounced it correctly, who is a senior software engineer at Datadog. He will talk about Rust and serverless. And then we are talking about Rust and continuous integration, a talk by Stefan Schindler, who is on location here today. We are going to have a premiere because I guess this is the first talk that will be streamed live from a Steam Deck. So I never had that in I don't know how many years of organizing a meetup. So I'm very much looking forward to that one. Next slide, please. Yeah, so if you want to engage with us, if you want to discuss with us, please join our Discord server. We are a very open community. If you have any question in learning Rust, or if you want to promote your events there or want to talk to us about anything, don't hesitate to join us on Discord. The URL is right here. And of course, you find it on our website and on Twitter and so on. And now Rainer, so you don't see that, but it's fantastic because Rainer runs between making photos and putting on the next slide. A little bit of community news. The Coder Dojo Linz is coming again. The next meetings are always listed at linz.coderdojo.net. And the next online meeting is on August 4. Also, that's it?
That's it?
We're done? Oh, we're done already. Fantastic. So
all the other communities here in Linz are currently on holiday.
Yeah, we are on holiday for 3 years now, roundabout. But there will be some upcoming meetups in the future, so we are going to keep you posted. Alrighty, I guess we can go on to Maxime. Is that correct?
Yeah, let's try to put Maxime on the screen. So, give me a second. Maxime, you are already in the stream, but people here in Linz can't hear you yet.
Okay.
I changed that now.
Hi, can you hear me?
So for the people on StreamYard, we are just switching screens. Don't worry.
So Maxime, can you try again to say something?
Yes, sure. Yes, sure. Can you hear me?
Yeah, we can hear you.
Cool. I can hear you as well.
Alrighty, so I don't know if you get the reverb at YouTube. Maxime, where are you joining in from?
I'm from Montreal, Canada.
I don't know if we had somebody in the US already or in North America. So this is super confusing. All right, I think. Maxime, I just hand it over to you. Welcome to Rust Linz, and I will be looking forward to your talk.
Thank you so much for the invite. I'm really happy to be here. It's great to see this Rust community growing and growing. So welcome everyone. I can't see you, but I'm sure you're all great. My name is Max, and today we are going to talk about Rust and serverless and why they're doing such a perfect match. So can I change the slide? Yeah, cool. So who am I? My name is Maxime David. I used to be French, but now I moved to Canada about 10 years ago. So I'm a Canadian citizen. I'm doing serverless at Datadog. I'm also an AWS community builder since 2021. If you don't know about this program, it's a great program led by AWS to share and to be part of a growing network of people passionate about technology and the AWS technology. I also started recently a YouTube channel. I have almost 600 followers, so definitely into the YouTube game. And I'm a big pizza lover, and this is really important for the demo, and you will see why in a moment. I'm also the creator of Lambda Perf, and we are going to talk about that in a moment. So yeah, without further ado, let's start. So first, I want this talk to be a bit interactive, and I want to show you the power of serverless first. So if you can scan this QR code and order a fake pizza and stay on the page. So I'll leave you a couple of 10 seconds to make sure everyone can scan it. Let me know. I don't know how you can let me know, but yeah, I'll leave the QR code for 5 seconds just to make sure you have time to scan it. So if you scan it, you should be able to see this web page where you can order a pizza. So I'll go for a deluxe pizza, and I can see that my order has been placed. So this is a client side. When I order a pizza, I want to track the progress of my pizza. So now the order is placed. Let's see if we have some current order. Wow, this is really cool. Thank you so much for playing the game. So I can see a lot of different orders. So I will put the pizza in the baked state. So you should be able to see, as you can see, mine has just been baked. So you should be able to see the status change directly on your phone. And yeah, I'm not going to spend 10 minutes on that, but yeah, just to show you that with serverless, and I will be back to the architecture in a bit, we can do some really cool stuff, such as like WebSocket. This is using WebSocket. And yeah, so we're creating a pizza. Then you have a manager interface when you can change the status. This will send a message over a WebSocket API, and the UI can respond to that event and display the status of the pizza. So yeah, this is all done in Rust, and we are going to talk about that in a moment. So I hope you're not waiting too long for receiving your pizza. It might not come, but yeah, thank you so much for playing with the demo. So now, what is serverless? So serverless, it's very hard. It's very hard to define, and everyone has his own definition of serverless. So I won't be more clever than everyone, so I'll stick with what AWS and GCP are telling about serverless. But yeah, both are mainly the same. It's focused on the fact that you're not focusing on the architecture, but more about building stuff. So it's a great developer experience, at least for me, and I'm sure if you're not using serverless and you want to try it, I'm sure you will be amazed by the developer experience that it provides. So 4 main things about serverless. You deploy code only and not infra. So we will see in a moment that when you deploy components such as a Lambda function, which react to events, you don't need to bring your own server. You don't need to bring your own API gateway. AWS has something for you, which is fully serverless. So you really focus on the business logic and not about the aspect of keeping your server up to date, managing certificates, and so on. AWS or other cloud providers such as GCP as well have serverless solutions, so you can really focus on your code. Another cool aspect is it's automatically scaling. So if you have let's say a pizza shop, and maybe on Monday it's closed, you don't want to pay for your servers on Monday because obviously there won't be any orders on Monday because you're closed. But maybe on Tuesday around midday, a big spike of traffic, a lot of pizza will be delivered, and now you need to spawn a lot of different servers. And this can be difficult in a non-serverless world, but for serverless, it's built in. You don't have to do anything. It will scale for you. If you use it correctly, you have a built-in high availability. So it means that if you deploy a new version, the traffic will spawn, will change from the V1 to V2. You have to do some best practice in the code, but it's generally built in. And the fourth and not the least is pay as you use. So it's usually billed by milliseconds. So the faster your function will be, or your container will spawn, the lower the price will be at the end of the month. So this is a big 4 of serverless. Of course, there's more features, but let's focus on that today. So you may already know serverless. We talked about AWS Lambda. We are going to talk about Cloud Run as well from Google, but it's way more than that. There are DynamoDB, S3. There are a lot of different serverless services, but yeah, today we are going to focus on AWS Lambda and Google Cloud Run. So let's start by AWS function. You can see that as a function as a service. So you deploy only a function and it will become a service. It will be event driven. So it will wake up by an event. It can be a HTTP gateway event. It can be a WebSocket message, just as we just saw. It can be when you put an object into a S3 bucket, it can wake up a Lambda function. And it's supporting almost any language. Out of the box, we have Ruby, Java, Go, Node, Python, and so on. And of course, we can bring your own runtime. And guess what? We are at the Rust meetup. We are going to talk about Rust. So as I said before, since it's not always on, if you don't have any traffic, your Lambda function won't be up. You have what we call a cold start. It means that the first request, or when you have a big spike of requests and your current instance cannot keep up to the pace of the incoming request, another Lambda function will spawn, another sandbox, and this is what we call a cold start. And the cold start is actually free. You don't pay for that, but you pay in terms of latency, because if your function is taking 5 seconds to start, well, someone at some point will wait for 5 seconds. And as you saw, I hope, actually, during the demo, there was no latency. Everything was super smooth. And we switch from, obviously, we are maybe, I don't know, 30 to 100. It's not big spike of traffic. But the point is, if we had like 1,000 orders, the website would have been super responsive as well. Trust me on that. So since the function is not always on, we have what we call a cold start and a warm start. So both are starting with an event because AWS Lambda function is taking an event. So let's say it's a WebSocket event or an API gateway event, HTTP request, for instance. So AWS will first download the code, start the environment. Underneath, it's a Firecracker VM. And then we have code initialization. So the yellow thing are for a cold start. And then finally, your function will execute. Let's say it's, I don't know, hello world, or put a pizza into a DynamoDB. So this will execute your code. On the second request, or when you have more traffic, every other request than a cold start will be a warm start. So we don't need to download the code. We don't need to start the environment because it's already there and the code has been already initialized. So then you just execute your code. So yeah, so this is a warm start and a cold start. And of course, if we want to have a lowest latency possible, latency, you need to make sure that, for instance, code initialization is really, really small. So I've developed a small tool, which is Lambda Perf. I don't know if you already seen that before, but it's an always up-to-date benchmark of cold start over every runtime. So I'm going to zoom a bit. I don't know how big the screen will be, but each yellow spot is one cold start. So if I refresh, in real time, you see what does it take to wake up 10 Lambda function written in Rust, in Python, in Ruby, in Node.js, in Java. And it's always up to date because it's auto-updating every day. Every day, every single Lambda function will be destroyed, will be recreated, and we invoke 10 times, making sure it's a cold start. We take the average duration, and this will be printed out on this website. And as you can see, Rust is the fastest, actually. And we are going to see why. And we are going to see why Rust is such a great candidate for serverless. If you care about latency, of course, if you're doing some asynchronous job and where latency does not really matter, maybe Rust is not the best option. But let's say we want to have a very low latency system. So yeah, if you want to see how does it work, it's fully open source on GitHub. If you want to contribute to a new runtimes, feel free. The aim is to have like a very open product. It's not biased in any way. It's just a hello world in every runtime. So yeah, Rust is winning for that. So yeah, download the code. There is nothing you can really do about that. I guess your Lambda function, it will not be like 1 gigabyte. So AWS has some internal mechanism to cache your dependency and so on. So should be really, really fast to download. This is a guess. It's not officially documented, but I guess there is some good optimization. Start the environment. Once again, you can do really something about that. A Firecracker VM will spawn. It's Node.js Go. It's the exact same underlying infra. But then you have code initialization. And this is where Rust could play a huge role. And this is what we saw in the benchmark. If you're using Rust, the code initialization will be faster. Let's see why. So yeah, I spoiled it, but let's talk about Rust for that, because we saw that Rust was best candidate for that. So why Rust has faster cold start? First, Rust binary can be extremely small. As you may know, there is no garbage collection in Rust. So the runtime footprint, the minimal code to run a Rust binary is extremely small, and it's hard to beat. For instance, I have nothing against Go once again, but if you start with a hello world with Go, there is a Go runtime inside this binary. So the binary will be a bit bigger, and we'll see some numbers a bit later. But Rust, there is no garbage collection, so the memory, the size of the binary is extremely small. And if it's small, it takes less amount of time to load into memory, and it's faster to start. The other thing is that Rust is extremely good at memory management. So you can have very tight control on number of allocation, size of the allocation, and so on. Because of course, if you're doing a lot of allocation on the heap, on the stack, the time to start the binary will be longer. So Rust is really nice candidate for that, because you can have control on that. Rust has also some very interesting building flag. So let's say you have your Lambda function written in Rust. What we can do is we can play with build flags, to make sure that the binary is extremely small and really well optimized. So the first flag is the optimization level. If you set it to Z, it means it's optimized for size. So maybe not for performance when it runs, but the binary will be extremely small, and it means that it will be fast to run. So the cold start will be extremely fast. Maybe the runtime duration will be a bit slower if you optimize for size and not performance, but that's a trade-off. So you can play with that and see how it affects cold starts. Second flag is LTO, means linked time optimization. So if you enable it, the optimization overall will be a bit better, but at the cost of a longer linking time. So if you're not in a hurry, it's really, for a hello world, it's a couple of milliseconds. Maybe for a bigger application, might be a bit different. But for serverless, once again, I strongly suggest you to try this flag. Then you have the code generation unit. By default, Rust is doing some local optimization of the code for each unit. So let's say you have 10 units of compilation. You will have a local optimization in each one of those 10 blocks. But it tends to be faster to compile. But of course, if an optimization can be done within 2 blocks, it won't be done. So if you specify that you only want to have one code generation unit, you are sure that all the local optimization will be done at the same place. Then you will have a faster binary at a longer compile time once again, but sometimes that's fine. And the last flag, I'm sure you already know what is a panic in Rust. You have this nice stack trace, which is really useful to debug. But for a Lambda function, maybe you don't need that. So you can strip it, and instead of outputting the full stack trace, you just abort, and that's it. So it will remove the code used to unwind the error up to the very top of the stack trace. If you don't need that, you can strip it. So this is for the build flags. So show me numbers now. For Rust Hello World Lambda function, the size with a the 4 flags I've just shown is about 722 kilobytes, so extremely small. For instance, once again, nothing against Go. I need to take another runtime for reference. So Go is 4.7. So maybe there's some flag that I didn't use, but I use W and S to strip the symbol table and so on, to try to have like as small as possible. But yeah, this is a no-brainer. It's almost 5 times smaller. So yeah, that's it for Lambda. And now I want to show you something. So for the connection, this is a Lambda function written in Node.js. And this is when someone is going to the website, it will receive a connection event from the WebSocket saying, I want to order pizza. So what we need to do to keep track of that is to insert something in DynamoDB, which is a table available, not a table, or like a database system from AWS. And what we want to do is to match the current ID of the connection to the order ID that we want to track. So if we go back here, for instance, here I have an ID. So if I change the status, then I can match the current connection to the current order ID to update the UI. So what I need to do is to read the events. So once again, Lambda is working with events, incoming events. So I read the events, I check the query string, I check if there is an order ID, then I put an item into DynamoDB. And if we want to have a look, so there's no one on the website currently. If I refresh, if I go back to my website, I should have an item here. Yes. So as you can see, it's fully real time. Nothing is hard-coded. So we have a connection ID. I say that it's connected, and then we have the order ID. So that's fine. If we look at the log connection, we can see that this function, the init duration, so the cold start duration, is about, I can zoom a bit if you want, is about 294 milliseconds. So it's pretty good. It's quite fast. But if we want to go a bit further, maybe we can rewrite it to Rust. And I'm going to show you the code in a moment. And in Rust, it's doing the exact same stuff. I will show you the code in a moment. And if you look at the report log line, the init duration is now 43 milliseconds. So of course, we saw with Hello World that Rust is beating Go, for instance. But as soon as we have a bigger use case, such as, it's not super big, but it's like taking an event, reading the query string parameter, and put an item in DynamoDB. For all of that, in terms of init duration, so loading the AWS SDK into memory and so on, we only take 43 milliseconds, which is, to me, like mind-blowing. It's super fast. And then the actual runtime, it's 99 to actually put an item, 99 against 572. So once again, the runtime duration is quite faster with Rust as well. So now I want to show you a bit of code. So I have a code here. It's a Rust code to deploy and to build the Lambda function. So the first main function is actually receiving an event. So once again, it's in a WebSocket proxy request. So these events are provided by AWS. So you just need to import the library, and we will have the proxy request. Then what we need to do, instead of hard coding the table name, you can read it for the environment variable, for instance. Then I take the order ID. Finally, I spawn a new DynamoDB client. I put an item, and that's it. So this is the exact same code that I've shown you in Node.js, but written in Rust. First, it's super fun to write, super easy to test as well, and super easy to deploy like any other runtimes. But yeah, so the code will be available open source if you want to have a look. But yeah, that's it for Rust, a Lambda function. Really simple. Just have a main. If you want to have a tracing, of course, that's always better. Put an item into DynamoDB, and that's it. And as you can see, the runtime goes from, the init duration goes from more than 200 milliseconds to below 50 milliseconds, which is pretty neat. So yeah, serverless is obviously not just Lambda. We have other stuff as well. So let's have a look at Cloud Run, for instance. So Cloud Run is a service from GCP, Google Cloud Platform, which you can see that as a Lambda function, but maybe a bit bigger. Let's say instead of having just one entry point, which is your Lambda function, you can have a full container. So let's say you want to have like a Express server in Node.js or Actix web server in REST. So it's really like a container, no constraints, no runtime API, no nothing. It's just a regular container. You ship it to Cloud Run and it will auto scale depending on your need, and it can scale to 0. And once again, if it can scale to 0, it means that you are going to experience a cold start as well. So I have done a small experiment that I'm going to show you. Here I have Cloud Run. So for instance, I have a Go container. So as you can see, very simple Go. I will listen and serve port 8080, and I will return hello from Go. I have the exact same stuff for Node.js. So hello from Node.js, just using Express. And for Rust as well. For Rust, I created a test to show you how a big enthusiast I am about Rust. But you should write test for everything, of course. But yeah, so you have an Actix web service, just spawn a hello root and hello from Rust. Very simple code, and I have deployed it here. So if we go to the Go, I will zoom it. It will say hello from Go, hello from Rust, and hello from Node.js. So the exact same cloud container for 3 different runtimes. Now let's add a benchmark of that. So I prepared a dashboard for you. This dashboard is directly available on the Google Cloud Console. So no instrumentation library, which could impact cold start, no nothing, just plain metrics. So let me zoom a bit. First, I will show you what I've done. I load test the 3 services. So sending a lot of requests, as you can see, a lot. It's not huge, but 150 requests per second. It's enough to spawn new containers continuously, because one container cannot handle that much load. So as you can see, each color is one runtime. So Go, Node, and Rest. And obviously, not to cheat, I send the exact same number of requests to both 3 runtimes. First things to note is the request latency. So once the container is warm, we can check how long the hello world is taking. And Go and Rest are almost the same, about 1.6 milliseconds. And I'm not sure why, but Node.js is a bit longer, but yeah, 1 millisecond, maybe that's fine. Just to print hello world, that's not a big deal. If you look at the 99th percentile, so let's say outliers, the longest request, Rust is winning as well, about half a millisecond. So I'm not sure this is really interesting, but yeah, just to show you the request latency, that's no big deal. What is really interesting is the container startup latency. So once the container is full of requests, we need to spawn a new one because otherwise you are going to wait too long. So the fact of spawning a new container, of course, you need to download the image. And in this test, I use the exact same image for the 3. It's a distroless Node.js and Debian-based image. The code will be available if you want to reproduce that at home. And as you can see, to spawn a new Rust container is about 119 milliseconds, which is once again absolutely mind-blowing. Go takes a bit longer, 144, but still okay. But as soon as you're hitting like non-compiled language, it takes longer. So maybe a bit more than half a second for Node.js. And if we look at the, yeah, this is, should have done that, but yeah, you get the point. 50 percentile and 99, and Rust is still winning. So the point is, like, when you need to scale out to handle more traffic, you need to first ask yourself, do I need this to be extremely fast? Or maybe it's a night job and I don't really care about that. But if you really need, if it's like client facing, maybe you need it to be really, really performant, and maybe Rust could be a good option here. So yeah, Cloud Run, container as a service, auto scaling, as I just mentioned, experiencing a cold start as well when the container is full of requests. Then you need to spawn a new one, and this takes time, and you need to be really careful about which runtime you want to use. Just did the demo, and yeah, that's it for me. I hope I convince you to at least have a look at Rust for serverless if you actually need it. But yeah, I could not emphasize how fun it is to write Rust for serverless. A great tooling. I mentioned AWS Lambda. AWS is doing a really great job for the SDK of writing Rust Lambda function. So it's really, really fun. Every incoming event are already supported. So DynamoDB, WebSocket, S3, a lot of different examples are available on the GitHub. So yeah, that's it for me. Let me have a look at the chat, or if you have any question.
Hi, Maxime. So fantastic talk. Thank you very much. I just moved in from the outside to have a spot where I don't hear myself.
That's nice.
So, and let me please apologize for giving the worst introduction in my career as a moderator.
That's totally fine. I'm really so happy to be there and to share my passion about both serverless and the rest. So thank you so much.
I don't see any questions in the chat, but I have a couple of questions.
Sure.
Since I'm doing a lot of serverless in Rust as well, I wanted to ask you, especially with GCP, you said that you were spinning up an Exum server, and you were showing that after a couple of requests that another container is being spun up, and you load basically the same image again. Do you have any numbers on how many requests are happening before a new container is spun up? So is there any difference between Rust and Node.js and Go? Because what we understand is that Rust could leverage multi-threading and handle much more requests, which is not possible with Node.js in that regard. So I'm really curious on your thoughts here.
That's a very good question. And to be honest, to be sure that container will spawn and not to send a trillion of requests per second, I capped the number of requests per container to 5, only 5, just to make sure that I'm receiving 5 requests, I need to spawn a new one. Because what I wanted to show was how fast was a new container to spawn. And to answer your question, unfortunately, I didn't have the number. But to be honest, that's a very good question, and I might have a look at that. Let's say we don't cap the number of requests per container, and we can see how many requests we could handle in Go runtime, Go, Rust, or Node. That's a good question, but unfortunately, I capped it.
Yeah, I think it also makes sense because you want to somehow recreate the same environment as you have in Lambda by saying, okay, I'm allowed that many requests and have a very small dimension for the container, like just half a CPU or something, and a couple of megabytes here. Because I think Rust works really, really well with small lambdas, where you just have a little bit of RAM because you basically don't take any RAM up at all because you don't have any runtime like in Node.js. So this makes a lot of sense to work in small environments. And I think this is also for Lambda a cost-saving factor because you can rely on those small ones. But speaking of Lambda, what I found hard is to develop Rust lambdas locally, especially if you think about all the environment tooling that you get from the serverless framework or with the dev tooling. I mean, it's mostly written in JavaScript or Python. You can mock everything and you can create those surroundings. I would be really curious if you have any recommendations on how you can develop lambdas safely locally without constantly needing to deploy something.
Yes, that's a good question. And actually, I gave a talk about that in DevOps Poland. So if you want to have a look, it's also about Rust. But yeah, I will summarize it here, of course. What I suggest is don't forget that it's not because we are using serverless that we do not need to respect good engineering principle. It means that it's an entry function, so it can be unit tested. You don't need to upload it to AWS, it run and say, oh no, it's not working. So you can do a lot of testing locally by using cargo test, like plain test. It's like a function taking an event request. You can mock the event, saying like connect, disconnect, and trying different things. So first, I would suggest do some unit tests because it will save a lot of time. Then, if you're using extra dependency, like third-party services such as DynamoDB, for instance, there is a lot of Docker-based image provided by AWS, and I use test container. So test container will spawn you a local DynamoDB locally, and then you can like talk to a real DynamoDB locally. So it's the exact same SDK. Same, for instance, it won't emulate the latency and so on, but you can actually do some requests. So you can see if the request scheme is okay, the table name is okay. So you can do a lot of different checks as well for test container. And last but not least, you actually obviously need to deploy to AWS to check, for instance, IAM permission, because maybe everything looks great locally, but you forgot to give the put item permission on your Lambda function, and boom, it's not working in production. So yeah, my suggestion is try to do as much as you can do locally, because the feedback loop is really, really small. But at some point you will need to deploy. But the latest is the best, in my opinion, just to make sure that you're not like over deploying just to check like do I need to read my environment variable. You can do the unit test locally. So that's my advice.
That's some really good advice, because this is actually the one thing that always bugged me when writing lambdas in Rust. And I came up with an incredibly complex service framework where I used Tower Service and attached them once to an exam handler and once to Lambda. But I guess just writing simple tests would have done it as well. So that's really.
I think I will write some blog post about that, because yeah, you're not the
Please
one,
do, yeah.
the only one to ask me about that. So yeah.
Please do. One more thing, I guess the last question, because I already see that, that Stefan is ready. I have the feeling that Rust effectively solves the cold start problem that we have with serverless, because I know you can wait those couple of milliseconds until one spawns up. Do you have any gut feeling on how much cost savings that you have in the long run, where you say, okay, you can call so many more lambdas, or maybe that you see that you need to have much less cold starts because they reply just so much faster.
That's a very
good. Get a really good drop in costs.
That's a very good question. And to be entirely transparent, I didn't use Rust in production for serverless. It's just for like experiment like that. And you can see, of course, we will gain some cost because the runtime duration is faster. So the number of milliseconds spent in your Lambda function will be smaller. So the bill will be smaller. But do I have numbers? Unfortunately, I don't. But maybe I can upgrade my talk to like emulate traffic for, I don't know, 1 week and see what will be the cost difference, because Lambda is really cheap, but it's going to be cheapest with Rust, I guess.
So what I love most about it, Maxime, is that I want to now try it myself as well. So it was a really inspiring talk. Thank you for showing all those great numbers and those insights, especially in GCP. I totally lack information on how Cloud Run Go. It was a Go.
Yeah, Cloud Run. Yeah.
Works in Google. So fantastic insights. Thank you so much. Thank you for tuning in from Montreal. And we had never somebody from Canada. It's the first time.
Thank you so much for the invite, and thank you for your kind words. It means a lot. Thank you so much.
And maybe you have some time if you are in Europe again. Maybe a trip to Linz or to one of our Rust events that are around Europe would be fantastic. Maybe we see each other at our Rust or something.
Sure. Thank you so much.
Right. Thank you, Maxime. Alrighty. And for the folks on the stream, please give me 1 second, because I will do a magic trick and disappear from this stream and go outside again and announce the other Stefan. So see you in a few seconds.
I'm currently out of ideas. So what can we do? I will remove. Let me think. No, we just hit. Very bad quality. Okay, got it, got it. But why do they hear something and I can't hear something? Okay. No, stream is not fine. Not yet. Not yet. Not yet.
Okay.
Feedback loop. Oh.
Hello. Welcome. I'm sorry. Hey, welcome everybody. Sorry for the quick technical difficulties. We just had totally different setup than we had before. But my magic trick is now totally gone. The worst magic trick in the entire world. But anyhow, I want to welcome you to our on-site talk now. I'm very happy that Stefan Schindler has decided to come again for a talk on-site because today will be his last day in Linz.
Yes.
Which I'm very sad about. So he will go back to Zurich, but I hope you will join one day or another here in Linz again. That would be fantastic. And yeah, so I don't want to keep you any longer. Without further ado, please welcome Stefan. And for the people here in the audience, give him a round of applause. And for the people in the chat, also put out your clapping hand emojis.
Oh, is that the chat?
That's the chat. Yeah.
Oh, nice. I can even see the chat. So I will be presenting from a Linux system called the Steam Deck. Oh, there's so much delay. Yeah, it will be nice. It's I think a 6 or an 8 core CPU, so it's an easy gaming handheld. And now it's running presentation. Yeah, you can follow my blog. What do I do? So I'm here in Linz to finish my master's degree. Should be done soonish. So yeah, end of the year, definitely, probably end of the month. I maintain a couple open source crates. On the Rust side, you maybe have seen Fretpool or parseint or sudo. I can highly recommend parseint because it just deals with all the prefixes. I'm starting a new job tomorrow. That's why I'm moving away from Linz. So the classical disclaimer, opinions are my own. My employer, TP, they are in a similar space, but yeah, don't speak for them today. And in my spare time, I organize another Rust meetup called Zürichsee, which is the lake of Zurich. So all around that lake, there's also talks. And Rustfest. If you want to join the Rustfest family event, you can in October in Brussels. So in Brussels, it's called eurorust.eu. Tickets are available, schedule is public. Oh, book a day early because there will be workshops that have not been announced yet.
They have been announced.
Oh, cool. Yeah. So they have been announced. Wonderful. Let's go to the table of contents or not, because I don't think you can read it. And for the people in the stream, you will just get what you get. So let's not waste any time. So continuous integration, CI. It's basically a thing to execute code on another machine. That's why I highlighted it here. It's a remote code execution. Very important. If you give access to someone with your to your CI will just run with the same privileges all over again. And like we had with the Lambda cache attacks, where someone figured out that /tmp is read-writable for all the Lambda functions, and you can read stuff from other customers. Same is true for continuous integration if it's not set up properly. And what does that mean, that's set up properly? Well, Docker still runs as root by default, and the default installation is in a Docker container. So your continuous integration job runs as root alongside everybody else. That's why there is Podman, which I can recommend. So you set Podman up and then do the mapping properly, and then it's not root anymore. It's just a user. And of course, you can use Kubernetes, K3s, for instance, and then configure that as the runtime or executor, but I will go over that as well. Why is it so very, very handy? Because it's bundled with the repository. If I have 15 different versions or branches, or on pull requests and merge requests and all of the things, and small things change, it will always build with the same code, even if I change the CI infrastructure itself. So that's very, very nice. And then we need some advanced features, right? Like we need specific environment variables. We need to have secrets for deployment or for pulling down proprietary data sets. We have caches sometimes that would be very nice. And we may have artifacts. So the difference between those two is cache is read-write, and you can manually delete it per repository. And artifacts are outputs that are generally uploaded to something else, like a website, through the GitLab functions. There's similar stuff on GitHub, but it's called slightly different. We also have variables in the scheduling. That's basically the templating. Oh, is the mic back on?
No, it's not.
No?
Stefan.
Am I gone? When did I clip out?
Stefan is not here.
No.
Stefan.
Support. Oh, he walked away with his phone, right? Did it disconnect? No, still connected. We're lucky today. We're very lucky. So how far should I backtrack?
Just 5 seconds ago.
Can't wait for a third device. Did we just lose the stream? Okay. So, yeah, I was with templates. So we can have symbols in our YAML file that will be interpreted. Yes, I hear myself again. Very good. And another very nice feature is triggering events in different repositories. Sadly, I cannot show that code because it's from one of my clients, but it basically works like this. They have an open source base installation, and whenever CI starts to run on the main, on dev and staging branches, it will send signals to a deployment repository with all the secrets and all the configuration for the production. And that part is very private. So it will just forward a signal, and you can see in the open source version if all your tests work. And then in the closed source part is the deployment. Did it actually deploy to the machine or not? Now, how do we think about stuff? So we have one GitLab CI.yaml file, which is called a pipeline. This is one thing that runs through. Inside that pipeline, we can have stages that are just blocks, and we define the stages in order, and they run in that order. But because that's too easy, there's also another mechanism called depends on. So we have a full dependency graph, which of course we can build loops, and then it will crash or just hang. So they have these two mechanisms. I personally like the stages because they're easy. But the graph is also very nice because it draws you a nice picture and it auto-hides stuff. And it's very similar to GitHub's matrix, where you can tell, make me a matrix over processor, architecture, and operating system. And then it just spawns 16 jobs at once for all the combinations or more. Another thing is we have per GitLab instance. So the web UI that stores the code, we have shared runners and non-shared runners. And if you have code on the public gitlab.com instance, I would recommend just add your own runner to projects that compile often or take long, because they reduce the amount of free time you have on the system. Yeah, if you don't want to be surprised, if you're close to this limit, it used to be 2,000 minutes per month. I think it's less now. Just add your own system, let your system run all the jobs, and there will be no more surprises. Fun fact, if you have a workstation, you can just run it in a virtual machine on your local machine, or in a Docker container on a local machine. If you're the only one that's linked to that runner. You trust yourself, hopefully. Right, then you can just have it running on the background. Could even be on a laptop, and with some smart trickery you could set it up in a fashion that the runner would not run when it's unplugged from the power, for instance. So when you code on the go and then go home to your office, just plug the machine in and it will realize, oh, now I can process the queue, and it will run all your CI. GitLab is smart enough to recognize when a job is no longer needed. So let's say you have a branch and you add 5 commits to it. It will not run all 5 commits, just the last one, unless you tell it to. But usually it's good enough to run the last one. All right. So costs, last talk had it as well. On the public instance, we have 1 hour limit and lower priority compared to the paid plan, which is 30 euros, little less per user per month. If we compare that to some random VM, which is like 5 euros a month, and looking at it for like half an hour every month to apply updates for unlimited amount of users, it's a pretty easy sell even to your boss. Disk space, just put something that has more than 5 gigabytes. 10 is probably tight, 50, good enough. Networking is usually free with servers, and yeah, because you usually pay for outgoing traffic. And a GitLab runner is usually pulling a lot of data in. So inbound traffic is usually free with all the servers. So that's very nice. And for caching, you can use an S3 compatible storage. Don't have to use AWS. Oh, and if you use AWS, be aware that they charge you for traffic within their data centers if the data centers are in different zones, and that can be very expensive. Just, yeah, be aware of that. So another project where I advise sometimes now is Trapped, because they have a lot of storage in one bucket and another huge lot in another one, and they cannot synchronize them anymore. So they just manually synchronize stuff that they notice is wrong. But yeah, they cannot afford to just download both sides, compare, and fix it automatically, because it's a couple terabytes and it's just very expensive. Another thing, privacy, safety, security. Deployment keys is a good thing. License keys, another thing. Sometimes you're not even allowed to run certain software on certain CPUs. So if you, for instance, have a, I don't know, Adobe license that is for 16 cores, and the shared cloud spawns you on a 64 or 96 core machines, you subtly breach of license. Would be really hard to blame you for that, but kind of, just put some old box in the corner and let that run it. Yeah, doing stuff local, self-hosting, yay. So here we see typical flow from the runner's perspective, and it's all HTTP. Who remembers long polling? Oh, a couple. So for the young ones, this is before WebSockets was a thing. Yeah. So, and sadly, it still works. It's still needed. Yeah. So long polling uses the TCP timeout, which is still 30 seconds. So it waits 25 seconds, and if there's no data, the server will reply with no data, and then the client will poll again. And do that over and over until there is data, and there is a chance that instead of waiting 30 seconds for the event that happens on the server side, we wait 10 seconds, and then we're 20 seconds faster. It's still slower than WebSockets because we have to reconnect all the time, but yeah, that's the thing. The right side, the far right side, is the executor. That's communication that depends on the plugin. And what plugins are these? Yeah, it's usually Docker. Let's be honest. Most people run it as a Docker container or have it as a systemd service, which I personally find very handy because with systemd we can restrict the service a little more without touching the service itself. So we can, for instance, say private temp. So the service no longer sees /tmp from the system, but it's locked away in some random directory that will change every restart. The service won't see it. You can also restrict the capabilities, although to be fair, it doesn't make much sense because most of the capabilities like reading, writing, and network connections are needed, and that's usually the dangerous stuff. Oh. Yes, someone moved an umbrella. So if we add this, we can also make an Ansible role. Probably can't read it. Don't worry. So it's installing an GPG key and then adds app. Let me scroll down. Then enables the systemd service. And then we add the repository as well. You see, this is distribution dependent. So when you are on testing, for instance, like Debian testing, or I don't remember what the Ubuntu bleeding edge is called, there is a chance that when the testing name gets announced, your updates will fail for a couple of weeks until GitLab itself has a new folder. So you can also hard code the distribution release or override it. Ansible is highly customizable, sometimes a little bit too much, and you can override almost anything. So the executors. So the first two, SSH and shell, are the most dangerous, basically, because it is what it is. It just opens a shell, either remotely or locally, and just executes whatever's in this YAML file. And that one is not contained at all. So no matter what branch, it will just execute the code. You shouldn't use that unless you have 100% control and don't accept any untrusted merge requests at all. Another one is Parallels or VirtualBox, where you spawn a virtual machine. There used to be one for KVM, but it was discontinued, sadly. There was also one for Xen, also discontinued. There is the Docker one, and if you just symlink the Docker binary to Podman, you don't have to worry about anything because Podman is API compatible. And there's a Docker machine plugin, which is the same as Docker, but just starts a VM first. That one is really handy, but it's experimental, sadly. And yeah. And of course, we have the Kubernetes one. And Kubernetes is great because you already have namespaces and whatnot. And yeah, the only downside is we have to run Kubernetes somewhere and have all the ingress and auto, blah, blah, blah. So for small installation, Docker is probably fine. Yes. So let's look at some code. This is from the sudo project. The sudo is one crate, one library, nothing fancy. Can you read it in the sunlight? Okay, nice. Image is a Docker image. And when Docker Hub announced that they would charge for stuff and just throw everything over, whatever, I was a little worried because I would have to update all these image paths like everywhere. They reversed the decision, luckily, because yeah, it was very, very stupid idea. And then yeah, you use the image. The image on the top level is the image for all the jobs. We can override per job as well. And then we have the test stage, which is the first part, this here, and then some name. This syntax has been deprecated, so now it will just reinterpret it as test::cargo. Well, it works. It's just one stage. That's all it is. I recommend outputting the compiler versions, no matter what language. And if you use Node, just say Node -- version or Java or whatever. Just print it. It will be logged, and then you have a much easier time figuring out why some feature is broken, or it gives you random errors or invalid syntax. Just check if the version is correct. Then we run a test. That's yeah what it is. This one is in debug mode. And then last but not least, we test all the example code, because this repository basically has a lot of example code because you cannot test it otherwise. So yeah, it is what it is. If you have questions, just like shout. I will skim the stream now.
No questions in the stream yet.
Yeah, just some ad for Hetzner. I don't like Hetzner personally. They have an anti-Tor policy, or at least had one. Yeah. Use IP projects or ungleich.ch. If you want to be CO2 neutral, then you can host your stuff in the Swiss Alps. Yeah, it's running off water power, so it's nice. Okay, next example, parseInt. ParseInt is a little bit more complicated because we have features now, and we have nightly. The difference between nightly and not nightly is the image line. So we just add, whoops. Oh, come on, double click. You add the tag nightly at the end. That's it. That's how we change images. And for features, we just run the test without flags and with flags. Yeah. It's not that hard, right? It's good to do. We can, of course, do more stuff. So this is from my master thesis. And here I use a different image. So I don't use the stock compiler. I use something that I built myself. This here. So I changed the registry as well. I'm hosting this one on GitLab. And I use JUnify because that allows me to print test coverage, like how many lines are covered in the test. Then for actual test coverage, again, printing the Rust version, testing the whole workspace. This workspace flag is very handy. So, because it will tell Cargo, yeah, go search, go deep, test all the things. And then we can modify the output format. You can see here we have, JSON. Then we have unstable options. That's why different compiler, report timings, and then here's a normal shell pipe. Oh yeah, and these little squiggles at the end, it's just new lines that I had to insert because it wouldn't fit on the slide. And then we calculate coverage by just running a normal build and then have LLVM coverage do the actual coverage reporting. But yeah, we need to have the tests running first because LLVM coverage will fail weirdly if the Rust code is somehow unsustainable. Like if you have syntax errors just in the tests, it will compile under normal circumstances, but then the coverage will fail because there's an error in the test. So we need to run the tests first and then build again. But hey, the CI does it. We will never forget it, and it will just work. And remember the artifact? This is an artifact. So the output of the artifact is some XML. And sadly, the latest version of GitLab broke this a little bit. I haven't fixed it yet. But you could just tell it, here's the report template for JUnit, which is a Java testing framework. But XML is XML. Just look into that folder, pull it out, and then add it to the branch. Yeah, I will fix that at some point. There's other formats. Don't remember. It's, I think 4 or 5 different coverage formats are supported. Maybe. I don't remember. Yeah. But you can find it in the docs which ones are supported. Now, another example is Color Blinder. It's a tool I wrote a couple years ago to simulate color blindness and different kinds. And then it will output a picture or a bunch of pictures or a combined picture, whatever you like. And for the pure Rust version, it's fine, just like sudo. But for the UI, for the GTK version, we need some dependencies. And now we have this before script. And this one will get run before every job. And I use that to set up the environment. It's Debian based, which is very nice. So we'll just tell update, upgrade, and then install. And then this is very handy install no recommends. So we don't get extra stuff we don't need. Just gives the smallest footprint, and smallest footprint means faster download times, faster runtime for the container. And then we install the libraries we need, like Pango and GTK3. Should update that to GTK4 at some point. And then we just run our normal script, just cargo test workspace. There you go. And it just runs through. And of course, we can play with stuff. So one of the additional features is deployment. And yeah, I have heard of Pages probably. GitHub has it, GitLab has it. It's a static site hosting service that's integrated into the hosting platforms. And the plugin is called Pages. So we just have to call the job Pages and put it in a stage deploy. And then whatever we copy into this public folder will get transferred out. Or we have to mark it as an artifact. And the plugin will then just look for this public folder in the artifacts and then put that onto their web server. It used to have some bugs. For instance, when you would trash the web service, it would just be empty. And then you had to rerun all the jobs. But that's pretty easy. You just go into the latest one, and then there's a little icon, just press it, and it runs the job again. And the nice thing is, it will run it at the same commit with the same environment. It will be very much the same. Unless we pull something from the outside, like time or downloads, it will output the same result in the end. Oh, before I forget, this only is a list of branches where we say, we upload the artifact only on the main branch or the release branch. I used to do some magic with regex and searching for a git tag and whatnot, because it also runs it on git tags. But it's hard, and the syntax changed, and this is way more reliable. And then we just have to protect the main branch and then push to main branch only with merge requests, and then we have release management as well. So, how do we deploy? Stage 0 is setting up some sort of trust, right? And SSH is really great for that, because we can have verification in 2 ways. So we have one token, it's the SSH deploy token. This is basically a private key, which we can generate on our machine with SSH keygen, and the output of that will be the value. It's just a one-liner, and it will be saved in. The other side is the server, right? We don't have, how is it called? The X509, the TLS trust chain, right? So we don't have that. We don't have a trust anchor with SSH. So we just ship it ourselves. We just record the known host files, put it into the environment, save. And then we are ready. We have another script. Again, just set it up. We install rsync, we install SSH, we create the folder, we place them in there. This is an old script, because in the beginning you could only have environment variables. Nowadays you can have files, but it's a little tricky if the folder doesn't exist. So I'll still keep it that way. Then we change the access permissions. Then we have some make deploy. This can be whatever. In the project, in this specific one, I use makefiles because I have a lot of reoccurring symbols, so I use makefiles templating as well. And then in the end, I just remove it. And this might sound silly because the container should get deleted, but with any garbage collection, there's no timing guarantees. It will delete it at some point, maybe next year, right? We just don't know. So I just delete the private key from the container. It will still be findable on the physical disk or the virtual disk, but it will be much harder than just opening a directory and there it is. So how much speed up can we get if we enable the cache? Yes?
One question
We do?
Chat, if you want to go cover it now. Caching.
The caching, yeah, it's actually this slide. Yes. So Rust is a little bit tricky to cache in the beginning because you have the target and the registry. Right. So the target is our build artifacts, and the registry is all the dependencies and the index as well. If you have Rust version 167 and older, it will copy the whole registry all the time. And that one, I don't know how big it is, but it's a couple hundred megabytes. So it will just download the index all the time, and then all the dependencies also, which is great for your stats on crates.io, but it's really slow. So on a big project I had with Actix, it just was pulling 15 minutes of dependencies and then building, because it had the debug cache already, and testing everything, it was just 3 minutes of that. So enabling registry cache with this handy little symlink. What? No, doesn't want to triple click. This one. It's a little hacky, but it works great. So it just say here, move that into. Before, script is important, because if we don't do it, the cargo command will already have created the structure. And with this, it will be redirected in our cache. So that's very nice. We could also cache the release binary, right? But I use that for deployment. And there's some weird bugs sometimes with caches on release mode, and I want to have a reliable deployment, and I don't deploy every commit. Maybe I deploy every 5th commit or something. So I rather wait the full build for release mode, which is, I think, 9-ish minutes. Yeah, the other one is the release mode. Yeah, 9 minutes instead of 20. Still good, still an improvement by 50%, but I don't have weird artifacts and I don't have weird errors on runtime. Yeah, does that answer the chat question? I think.
Is approximately 30 seconds to 45 seconds behind.
Mhm.
So we will know in approximately a minute or so.
Great. Yeah, I see GitLab. Yeah, GitLab has great runners in general, but they run in the Google Cloud, and I don't trust the Google Cloud. So yeah, I won't use them. But sometimes that's funny. If you have a runner on old disks and not enough RAM, it will be very slow, because the disks are just slow. And sometimes you notice weird lags in the log, and that's when there is a flush somewhere. So if any part of the whole chain does a flush, like pip does at the end of installing dependencies, or some programs do it when they crash, they write the core dump and then they flush. So you'll get weird timing artifacts in the environment. So I think we waited half a minute and I don't see anything. Yeah. Moving on. So an S3 cache bucket. GitLab has a very good retention policy for artifacts. It's just 30 days and the latest one. So we don't have to worry about that unless we deploy to production like 50 times an hour. It just works, right? Give it a little breathing room and it will clean up after itself. For the cache, it's not so clear, but it's a cache. So as long as the transfers are complete, right? So what I mean is when the client starts pulling a cache file, as long as the client receives the cache file fully, it will be fine if we delete it right after. Because the client will, client means runners, the runners will just search according to a scheme on this S3 bucket. Is there a cache for this repository, for this job? We can even add our own mechanisms and templates for this pattern. If it doesn't find it, it will just create a new one. And if it finds it, it will download it and then overwrite it when the job is over. Plus, we can manually clear. Yes? Yeah, so the question was, why create a remote cache and not a local cache? It's a very good question. In the beginning, you could do that. So I had a folder /cache, and I would just throw everything into that one. I don't know why. It's probably to do with the Kubernetes support, but I don't know. I'm also a little sad because now I would have to run another service just for the cache. It seems silly. So yeah, currently I'm not caching for most of my stuff. It's just the stuff that's already public, open source code anyways, that uses the cache, and everything else just takes longer. Yes, another question. Yes?
And the pipeline for the test runs around 7, 8, 9 minutes.
Mm-hmm.
And I tried to enable caching and the backing up the cache at the end and redeploying it to the runner eats up all the speed improvements.
Yeah, so someone from the audience had their own experience with caching, and apparently caching all the things took longer than the game was with the cache. Yeah. Sad, but yeah. Was NTFS involved with any of that? Okay, yeah. Yeah, if you run NTFS and lots of small files, you will be sad. So Microsoft's latest recommendation is use their new file system, the ReFS, in a second partition, because you cannot boot from that currently. It's supported in Windows 10 with the latest service pack. I mean, what's it called now? It's not service pack. Yeah, and Windows 11 supports it too, and the server as well, the latest one. Okay, so of course not the home edition. We're just talking to professionals. I mean, where would you be if the education edition was still the same feature set as the Pro, right? It is not. Yeah, I don't know, maybe they changed that back, but we'll see. If we run Linux, then very popular Minio. It's just one binary, just download it, configure it. Please set a password if you do it. Like, don't be like the CIA that loses lots of spy data over an S3 bucket, or the TSA, which uses the no-fly list over an S3 bucket. Yeah, and so many others. Yeah, please set the password. We don't need another FTP leak. Oh, it doesn't scroll. Sad. Okay. We can influence the cache, by the way, in the steps in our repository. So we can say for the deployment cache, we use a different pattern than for the testing path. Right? So we can prefix stuff if we want to. Otherwise, all jobs in one repository share the cache. But as I said before, I would not cache production releases anyway. So yeah, but you can. So conclusions, yeah. In my opinion, running a runner is very low effort. It just works. You get updates every now and then, but I have never had any trouble. Manage the S3 if you want. See if it even brings any benefits. We'll see. And most of the stuff I told you works for any system, right? Like GitHub's, or I'm pretty sure IBM has their own stuff. Yeah, and if there's no more questions, then I think we made it. We have more questions?
Alrighty, so thank you very much, Stefan. So first of all, it's the end of the talk. Big round of applause, please, from the audience for Stefan. Alrighty, and I have seen that you already answered a bunch of questions during your talk. So I think, what about people in the chat? Do you have more questions? People in the audience, do you have more questions? Or is it something that we can talk over a drink? You are thinking about something. I can see it in your eyes. Okay. Alrighty. If we don't have any questions, then I want to thank you, Stefan, for being here one
Thank you,
last
Stefan.
time before you go. Yeah, that's weird, kind of. But thank you for being here one last time before you go back. I think we will meet each other again at Eurorust in
Yes.
Brussels. So people in here who is going to Eurorust, even if you are cool. So
Yes,
I
me
am.
too.
Me too. You too.
Yeah.
Fantastic.
Yeah.
And there are actually two. Yep, I've looked it up. There are two workshops. I'm doing refactoring Rust the day before the conference, where we take some weird spaghetti Rust code and apply traits and design patterns, etc., make something beautiful out of it. And Luca Palmieri, who has written Zero to Production, is giving a workshop on adding telemetry to Rust APIs. And if I wouldn't give a Rust talk myself, I would go to his workshops, because this is actually a topic that interests me very, very much. Alrighty. So, and with that, I think, Rainer, we are good to close it down. One more thing, we are currently prepping up our August meetup. So we now have a preliminary date for August 18. We might move it a little bit depending on how Matthias is coming to Linz or not. So we need to discuss that. But it will most likely be a Dynatrace, which is just over there. So for you people in the chat and on YouTube, you just need to move your notebook for about 500 meters. Basically, then you are here as well. No, I'm just kidding. I hope you see everybody from YouTube again. I hope I see you again, and I think kind of we can stick around a little bit longer. Yeah. Okay. So, and with that, thank you for being here at the Rust Linz Revival 2023. It's fun, and I'm happy that we are doing it again. And see you next time.